Hi everybody, welcome to lecture number 3, Network Programming, UDP Sockets. So in this lecture, what we are going to discuss means, we are going to discuss these 10 topics, UDP Introduction, Socket Programming with UDP, Datagram Packets, Datagram Communication, Datagram Packets, Key Methods, and we are going to discuss about the step-by-step UDP socket server-side creation, step-by-step UDP sockets client-side creation, and we are going to discuss about the client-server socket interaction and UDP client-server, comparison of TCP and UDP client-server, UDP client-server with two clients, that means with more than one client, how to handle more than one clients in UDP. And finally, we are going to discuss about the flow control. So these are the 10 major topics that we are going to discuss in this particular lecture. UDP. There are some fundamental differences available in creating the UDP applications and TCP applications. We cannot have the same procedures or the same steps we cannot follow for both the TCP and UDP sockets. So as we already discussed in lecture number 1, UDP is connectionless, UDP is unreliable, it is a datagram protocol, quite unlike the connection-oriented reliable byte stream provided by the TCP. So we already discussed about this in lecture number 1, TCP is reliable, UDP is unreliable, TCP is connection oriented, UDP is connectionless. Okay, all these points we already discussed in lecture number 1. You can refer lecture number 1. Then some of the popular UDP applications. There are so many applications available, UDP applications. Some of the very important or very popular UDP applications are DNS, domain name system or domain name service, NFS, network file system, SNMP, Simple Network Management Protocol. So these are all some of the examples for UDP applications. Now, so we already discussed almost the same points repeated here. It is a connectionless and unreliable service. And there is not an initial handshaking phase. So there is no three-way handshaking. If we take TCP, in TCP you will be having three-way handshake. But here we don't have any three-way handshake process. So does not have a pipe. Okay, UDP does not have any pipe concepts. Transmitted data may be received out of order. So whatever the data you send in the order, so it will be different. In the receiving end, they are not going to receive the data in the same order. And sometimes the data may be lost. Server must extract the IP address port of the sender from the received datagram. So if any packet is received means, so from that particular packets only, okay, the server is going to read or the service is going to learn the IP address and port number. Now, as far as socket programming with UDP is concerned, so no need for any welcoming socket. You no need to create any welcoming socket here. No streams are attached to the sockets. So the sending host creates a packet. So just a packet will be created by attaching the IP destination address and the port number to each batch of the bytes. So just adding the IP address and port number is enough and you can send it. So the receiving process must unravel to the received packets to obtain the packet information bytes. So whoever receiving the packet, so they are going to do all the things. Okay, they are going to extract the IP address, the port number, data, everything from the packet. Now, so we are talking about the datagram packets. So generally the datagram packets are used to implement a connectionless packet delivery service that is supported by the UDP. So each message is transferred from the source machine to the destination machine based on the information which is contained in that packet. So based on the source IP address and the destination IP address, source port number, destination port number. Then each packet needs to have a destination address and each packet must be routed differently. So we cannot say all the packets will travel in the same route. okay, in UDP. So the packets may routed through different networks or through different routers. So that is the reason, okay, in the destination, the UDP packet, that means the datagram packets will be received in different order. Okay, we are not going to receive in the same order. So the packet will be received in different orders in the destination. So packet delivery is not guaranteed here. Maybe there will be some packet loss. Okay, there is no retransmission concept. So if we take a datagram, so every datagram must have the port number, the host IP address, length and message. Okay, you can read it from right to left. Okay, the port number should be available. So the host address should be available in the datagram packet. The length of the packet is very important, and the message. That means this is going to be your payload. Okay, so whatever the data you are sending, that is going to be your message. Now, datagram communication. Again, we are going to talk about Java programming language here. So Java supports datagram communication through the following classes. So there are two different classes available. One is a datagram packet. So this is the name of a class, and DatagramSocket. So these are the two different classes which are available in Java. Okay, so these are the very important classes available for creating the datagram sockets. That means for creating UDP sockets. So inside the each and every class, okay, if you take datagram packet class or datagram socket class, so in that you will be having a lot of methods. Okay, there will be a lot of methods available. So what are the methods and all we are going to discuss in the coming slides. Now, so the class datagram packet contains several constructors. You can use the constructors that can use to creating the packet object. So one of them, so you can see here, so they are using the datagram packet this class. So by using a constructor class, they are going to create an object. So what are the parameters available here means, so the first one is going to be the buffer. Second one, it is a length, that means the IP address length. Then sorry, this is the length of the buffer. Then IP address, then port number. So these are the four parameters. So the buffer, length of the buffer, then INET address, that means IP address, and the port number. So these are the four important constructors, that means the parameters you can use to create, okay, a class. That means sorry, an object. Then, so the datagram packets have many methods. So there are a lot of methods available. Okay, datagram packet class. So this class is having a lot of methods. So the key methods of datagram packets. So what are the methods available means, the first method is called get data. So this is used for return the data buffer. Then get length. This is used to return the length of the data. That means how many bytes of data you are sending. Then send data, set data. So this is sets the data buffer for the package, for a particular packet. Set length, sets the length for this packet, for a particular packet. Then the class DatagramSocket supports various methods that can be used for transmitting and receiving. So this is for creating the packets. Okay, these methods are used for creating the datagram packets, for transmission and receiving. Okay, that means for sending and receiving the datagram, there are a lot of other methods available. So the first method is send. Okay, send, and second one is the receive. So these are the two different methods, key important methods for sending the datagram packet and for receiving the datagram packet. So send whatever the datagram packet you want to send. Okay, receive. So this is the class, and we are going to create an object for that. Now, so we are going for step-by-step UDP creation. That means on the server side. Okay, what are the steps available? Okay, we are going to discuss on the two slides. Then we are going for the client side. In client side, what is happening? Okay, step by step of UDP socket created in the client side. So these two things we are going to discuss now. Now, I'm going for the server side. So first thing, what we are going to do means, so I'm going to use DatagramSocket. This is the name of the class. I'm going to create an object. So with a port number 1, 2, 3, 4. This is going to be a port number. So I'm using a port number. So we can say it is also a concept of binding. Okay, that means for a socket, we are going to assign a port number. Okay, I'm now in the server side. Then the next one, I'm going to create the buffer. That means the data, okay, to be stored. Create a buffer for the incoming datagram. So every socket should have a buffer, socket buffer. So the buffer will be used to store the data. So we are creating the buffer. The size of the buffer is 256 bytes. Then create a datagram packet object for the incoming datagram. So we have to create a packet. So datagram packet, this is the name of the class. I'm creating an object here. Okay, impact is the name of the object. So here you can see buffer. I'm using the buffer plus the length of the buffer. So this is going to be the in packet. So this will be used for incoming datagram. Okay, so we are creating an object. This is an object for the incoming datagrams. Then the next step is accepting an incoming datagram. That means a client machine is giving a request. So we are going to receive the packet. Okay, it is not exactly accept, it is receiving the packet actually. Okay, there is no concept like connect and accept here because this is UDP. Only in TCP only we have the concept of connect and accept. Okay, connection request and accepting the connection. Here simply the packet is going to come, we are going to receive the packet. Now you can see by using the receive method, I am going to receive the packet in the incoming in packet. So this is the object we already created in the previous slide, in packet. So in packet, I am going to receive the packet which is going to come. Then from this in packet, we have to find what is IP address. So the IP address of the sender, okay, whoever sending the data to you. So we have to find the IP address. Now from the in packet, I am going to get the IP address and I am going to get the port number. So whatever the IP address, I am going to store it. Okay, we are going to store it in the client address. Okay, and this is the name of an object and client port. Okay, we are going to save the port number here. Then receive the data from the buffer. So the data is available in the buffer. So from the buffer, we are going to receive the data. That means string message. So this is the object. So in the message, I'm going to receive the packet. Receive the data. So from the in packet, get data. Okay, get data. So 0. That means starting from the first byte. That means the 0, 1, 2, 3, 4 like that. So starting from the 0 to the length. Okay, the packet length. So from here to here, I'm going to read the data. So okay, 10 bytes means from 0 to 10. Okay, I'm going to read the data. So the data will be saved in the message. Then the next one is we have to create a response. Okay, we received a packet. Okay, from someone, from X. So now what I'm going to do? I'm going to create a response. Okay, I'm going to give a response to that particular person. So for giving the response, so I'm going to create a packet which is going to be the out packet. So the name of the class, datagram packet, this is the name of the class. Out packet is the name of the object. So I'm creating. Okay, so what does it means? You can see here the client address. We already have this client address here. Okay, we got the client address and client. Okay, port number we have. So I'm using the client address. I'm using the client port. Okay, so this is going to be the IP address of the receiver. Okay, so then I'm going to have the response length. Okay, this is response is my data. Okay, that is the data I want to send. So response length means you can tell it in bytes. Okay, 10 bytes, 20 bytes, whatever it is. Then response dot get bytes. So this data I'm going to send it. Okay, to the person who gave me the request or who gave me the packet. Okay, previously in the previous step. Then the next one is I'm going to send the response. So the response is ready in the out packet. So now I'm going to send it. So DatagramSocket dot send. This is the object. This is a method, and this is going to be our the packet which we created. That means the message is available in this. We have to send the message. So now the message is sent. Then finally, I'm going to create my I'm going to close my socket. So DatagramSocket object dot close. So I'm going to close a particular socket. So this is the steps. Okay, there are 9 different steps available in the UDP server side. Now I'm going for the UDP client side. Okay, so 5.2 is going to be step by step UDP sockets client side. So in the client side, what is happening means, okay, the same thing, almost the same thing will be available. Create a datagram socket. Yes, we are going to create a datagram socket. So this is the object. We are creating a datagram socket. Then create an outgoing datagram. Okay, so in the previous one, we discussed about incoming packet. So here we are creating an outgoing packet. So datagram packet, I'm going to keep the name of the object as out packet. So I'm creating with the IP address, port number, length and the message. Okay, these are the 4 different parameters. Then once if the out packet is created, I'm going to send the out packet. So send dot out packet. So this is the name of the object datagram socket dot send. Okay, output or out packet. Okay, output packet we created here. So we are going to send the out packet. Then the next one is create a buffer. Okay, we already discussed you need a buffer for the socket. For the incoming datagram, I'm creating the buffer with the size of 256 bytes. Then create a datagram packet object for the incoming one. So this is for receiving the packet. Okay, so I'm going to create a object. Okay, in packet, this is for receiving the data. Now I'm going to receive the data. That means the in packet, whatever the data comes, I'm going to copy it here. By using the receive method, I'm receiving the packet. Then finally, this is going to be the response. Okay, the response string. So response, okay, it is a string. Okay, that means the message whatever I'm receiving. Okay, this is going to be available in the response. So I send a message. For the message, whatever the response comes, okay, that is going to be available in this response. So this will be sent by y. Okay, I am x and this is sent by y. Okay, so this is. Finally, I'm going to close my socket. So these are the different steps available in both the client side and the server side. So the same thing is now it is given as a a diagram. Okay, they are giving the steps. Okay, they are taking a server side here and they are having a client side here. So in both the sides, okay, what are the steps available? You can see here. You are creating a socket. You are fixing a port number. Okay, port X for the incoming request. Okay, then you are creating the object here. If you go for the client side, the same thing. Okay, the socket is created. So you are going to, okay, this is going to be a datagram socket. Okay, then exchanging the message. So from here, the message will be created and the message will be sent. So now here for that particular message, you are going to give a response. Okay, so here you are going to create an object. That means the message you are going to create, and here you are going to create the response. So the response you are going to create, and finally both the sides you can close the socket, or in any one of the side if you close the socket also, it is enough. Okay, the socket will be closed. Then the next one, the same example. Okay, we already discussed. Okay, so that means from the keyboard to the monitor. Okay, that means if you type something in the keyboard, so it is going to your network and you are going to get some output. Okay, how these things are working. So it is almost the same concept. Okay, whatever we discussed in the previous slide, it is going to be the same concept. Now, if you see this picture, you will understand very clearly about the UDP sockets. So if you take a UDP client server, now you can see here in the server side, you are creating a socket, you are binding it to a port number. In the client side, you are creating a socket. So here we don't need to bind anything. Okay, simply you are going to send the data. So if you are sending the data, you are going to capture the data by using a receive from function. Now from this packet only, you are going to get the IP address and port number of the sender. Then we are going to give the response to him. Okay, so here you can see there is no accept. Okay, there is no like listening state. Okay, so we don't have anything like that. So just like that, once it is binded, directly you can send the data and then you can get the response. So finally, in the UDP, that means in the client side, the connection is closed. Now, if you in the next slide, you can see, you can compare both TCP and UDP. Okay, this will give you a very clear idea. In TCP, you need, okay, binding. After binding, you need listen. Okay, you need to put your socket in the listening state. Then someone is going to give connect. So a three-way handshake will be going on here. Okay, you are going to accept it. A three-way handshake will be going on here. But whereas here there is nothing like that. You are not going to. Okay, the socket is not going to be in the listening state. You are not going to send any connection request. No connection response. Okay, there is nothing. But after that you can send and receive the data. So here you are using the write method, write, read and write. But here you will be using send to and receive from. Okay, send to and receive from methods will be used. So by using the send to and receive from, you are going to send and receive the data, whereas here read and write will be used. Then finally, you are going to close. Okay, you can see here the server side close is available, and also in the client side, okay, we are using the close method. But here any one side, if you close, it is enough. Okay, automatically it will be considered as the socket is closed. Okay, so this is a comparison of TCP and UDP client server. Then the next one, the next very important is how to handle more than one clients. Okay, how to handle more than one clients. That means 2 clients, 3 clients at a time. Okay, how to handle. In TCP, you will be having a very beautiful concept. Okay, that is called the fork. By using the fork method, a child process will be created. Okay, a child process will be created. So with the child process, okay, over the client, okay, client 1, client 2, client 3, it will be created, it will be connected with child 1, child 2, child 3 like that. But here we don't have any like fork function will be used here. So we don't have any child process, creating the child process and all, it is not allowed here. So here only a single server is going to handle all the clients. There is no multiple clients here, multiple servers. Okay, multiple clients will be available, but only one server will be available. A single server is going to handle all the clients. There is a queue concept, okay, taking place in the UDP layer of the socket. So in the queue, all the clients will be waiting. Okay, so each UDP socket has a receive buffer. Each datagram that arrives from the socket is placed in that receive buffer. So this already we discussed. There will be a buffer, receiving buffer. So in the receiving buffer, whatever the datagram you are receiving, it will be placed in the receiving buffer. So the buffer has a limited size. Okay, we already discussed in our example. It is only 256 bytes we used. So the size of the buffer is going to be a limited one. So it is possible to have a dropping. Suppose if you receive more data, so automatically there will be a loss. Okay, data will be dropped. So if a datagram is lost, the client will wait forever and timeout is needed. There is a concept of timeout. Okay, this concept should be configured. Okay, by default it will not be configured, so it should be configured. Then, so when an iterative servers used, so iterative servers means like when the server process knows in advance how long it takes to handle each request, and it handles each request itself. So here we are not going to use more than one client. That means the fork is not used, as I already told. Fork function is not used. So if you have fork function, if a request comes, immediately you are going to create a child process. The child will be connected. But here only a single server is going to handle everybody. Okay, a single copy of the server runs at all times. A client may have to wait if the server is busy. So if one machine is now sending and receiving the data, means the next one, suppose if the next connection comes, automatically the next connection should be wait. It should be in the queue. Okay, it should be in the queue until the first client completes its job. You can see, you can understand this. This is one machine, a single server. Okay, there are two clients available. So the first client is connected, sending and receiving the data, means the second client is going to wait. Okay, the second client is going to wait at all. Once the first client is removed completely, completed its task, then the second client will be connected with the server. Okay, so this is the concept of the concept used in the UDP. Now, flow control. So what is flow control means? Flow control is a very good concept which is available in the TCP to handle the speed difference. Okay, to handle the speed difference between the client and the server. So some machines will be very fast and some machines, okay, will be very slow. So in order to manage the speed difference between two machines, the flow control concept is used in the the TCP. In UDP, there is no flow control concept. Okay, flow control is not at all in use. If a client sends the UDP datagram very fast to a slower server, the number of datagram received may be smaller than the number of datagrams sent. So I'm just talking very fast. If you are not able to receive, means finished. Okay, whatever I'm talking, it is going to be dropped. So if one machine is very fast, the another machine is very slow, means definitely in UDP there will be a lot of data loss. Okay, so the reason, what is the reason means buffer. There will be some limitations for the buffer. You cannot have the buffer like infinite. No. So there is a limit. So whenever the buffer becomes full, automatically the datagram is going to be dropped. So increasing the socket receiving buffer may help to some extent. You can increase the size. To some extent it may help. So to some extent it may help you to fix the problem. It may help you, but it is not going to fix the problem. Okay, it is not going to fix the problem. So there is no flow control concept in UDP. So this is going to be a drawback. Okay, completely a drawback only. So thank you. So with this, we are completing lecture number 3. Thank you very much. Keep watching.